observings that you've done. Go ahead. Good.
Are there any reasonable power telescopes that are on the net that people can look at?
Yes, there are, and I should put that on there. That's real good. Yes, there are web-based telescopes that you can use. I believe just Google Hangouts where they do that. I need to look into that. That was kind of a good point. Thanks.
You know, they would bring stuff to some of the science fiction conventions with his telescope. And look at Saturn, you can see the moons going by.
I think I saw moons last night. You definitely see through the rings and see space through the rings.
But it was like interesting to discover that the rings aren't always a ring. Sometimes we're looking at them straight on. Other times, they go tilt or tilt.
Mm-hmm. It was several years ago. A couple of years ago, the rings were at an equinox, which was flat on with us, and they were seeing some really interesting things in the ring planes during that time. Now it's about an angle about like that. It's really cool.
I was just a little bit confused when I first heard about the last transit of Venus. Maybe you can explain better to me, why is it that we can't see it anymore? Why the ecliptic and all the planes, and then we're at a 42-degree angle? I heard stuff like that, and I'm just like,
The Venus and the Earth, the way they're angled in the orbit, they are slightly off. They're not directly flat on. If they were directly flat on, we'd have a transit all the time. But Venus is a little tilted toward us, and what it is, I think it's like there's 117 years between, and then 8, and that follows that pattern. There was a transit in, I believe, 2004. Yeah, 2004, and then 2012, and they're like clockwork. But it's because of the cant of Venus's orbit to us. And when you think about it, I mean, for that little thing to go in front of the sun, you've got to be directly on.
It's the same reason why we don't have eclipses of the moon every cycle, because the moon's got a tilt relative to the sun, and so its orbit isn't exactly in the ecliptic. And exactly what he was saying, it's because of the fact that they're not in line that you get the 115 years, 105 years, and then you get 8 years, and then it's 105 years, and then it's 8 years. And that's just because of the cycle.
I'm going to show you a video here. I hope this thing shows up, and I am going to run it tonight. I showed this yesterday. This shows, it's not sure what I wanted.
You can see that one.
Yeah.
Should we go in that one?
There we go. All right. This, can you see that at all?
Yeah.
All right, down in the corner, what you're seeing is starting in 1980, we knew of about 9,000 to 10,000 asteroids. What you're seeing here, that's the orbit of Jupiter. There's Earth. Anything that you see flashing there is an asteroid when it's discovered, and then it goes on its orbit. And one thing you'll notice is it's always on the night side of the Earth, obviously, because the telescopes are looking at that. But so we knew of 9,000 total asteroids in 1980. Here we are in 86, and that number's up to 12,000. And I remember in the early 90s hearing about near misses every month or so. And you can go to the International Astronomical Union site right now and get a list of the near misses that have happened for the past week. Okay, so 1990, 10 years later, about double the number of asteroids we have. And the asteroid discovery is getting a little more there. Well, in 1995, Congress mandated that we find all asteroids larger than 1 kilometer in diameter. And in 2005, they said now it's down to 140 meters. So after 95 years, you're going to start seeing the discovery rate go up drastically. And it's really interesting to see the curve since we've started doing this. The discovery rate for 1 kilometer has just completely leveled out. They think they found all the ones 1 kilometer. The discovery rate for all the other ones is an angle like that, and it's still going up. It's not level stop. 2000. Take a look at that. This is your asteroid belt. Now take a look also how far away from Jupiter these guys are, and how close they are to Mars.
Oh, yeah.
Take a look at that. Blam, blam, blam. Now look how that's filling up. The yellow ones are Earth-approaching asteroids, the ones you see in there. The red ones are near-Earth asteroids, and potentially hazardous asteroids. And take a look at the sea of those the Earth is swimming in. So 2005, this is when they mandated that they find the even smaller ones, and the discovery rate is going crazy. Now, in 2010, you're going to see a different discovery pattern, and it'll be very obvious. Look how that's filled up. 400,000 by 2008. 2009, we're up to almost 500,000. Now take a look at here's the pattern I'm telling you about right there.
Wow.
That's the NEOWISE. That's a space telescope that's it's able to look tangentially. So again, let's stop this thing. So, that's your asteroid belt. And I took a look at the International Astronomical Union, and this number here today is 617,000. There are 9,000 Earth or near-Earth asteroids. So, we knew of 9,000 asteroids total in 1980. Now we know of 9,000 near-Earth asteroids and 617,000 asteroids total. Here's some other interesting things going on. You may have heard of Trojan points or L points. Here are what some asteroids do around Jupiter. Now what you're seeing here is Jupiter stationary. Take a look at the way these things orbit. That is freakish. That is just celestial mechanics, the beauty of celestial mechanics. I absolutely love that.
There's the L4 and L5, the leading and trailing, and then you have the one on the opposite side.
That's the L1, isn't it?
Well, L1 is actually near,
L2,
is
isn't
in
it?
front of it, but I think that one's actually 3.
Yeah, and then we flip over to the Trojans. And I always thought the Trojan points, they'd just be orbiting, a little bit like that. No, the Trojan region there is huge.
In the gravity sense, it's a very shallow bowl, so it doesn't take a lot of energy to knock it in or out. But and because it's very shallow, it tends to just float around in there because all the other things disturbing them just make it tend to pull around like that.
This is the same data from the other one, but this shows you your asteroid belt and all those scary asteroids. I just love the center of that. I hate the fact that we're in that. But this, I take it and flip it sideways. So if you ever wondered how big the asteroid belt is, that is what it looks like. And take a look, there's stuff just up, down, left, right, all over the place.
It used to be a planet, right?
Well, the asteroid belt is actually stuff that never made it all the way to being a planet. You know, I talked yesterday, we were talking about Vesta and Ceres. Both of them were well, Vesta was on the way to being a planet. Ceres is considered a dwarf planet. It differentiated and it has an icy outer region. But Vesta it differentiates. It's got an iron core. It's got a crust. And there's several asteroids that are from Vesta, an impact on Vesta. There's a family of asteroids. The asteroids in the asteroid belt you also got to consider. Now, Ceres is, again, it's covered with probably silt and ice and stuff like that. A lot of the asteroids, they're not just rocks or metal like this stuff. They can have volatiles and things like that, fucking waters and methane and stuff like that. So yeah, there's a lot of stuff in the asteroid belt that is left over from the solar system forming.
you mentioned Ceres yesterday, and the probe going there. Is it possible that it might even have a vestigial atmosphere?
It might have an atmosphere. It might have a subsurface ocean like Europa. Ceres is is in the asteroid belt a lot closer than Europa and the Jovian satellites or Saturn. They measured the surface temperature on it as negative 35 degrees, which is a lot warmer than what you're going to find out at Jupiter. And we don't have the horrible environment of Jupiter to go out and try to have a probe survive in. Jupiter is just nasty. There's radiation here like crazy.
Kind of going back to that first image of Jupiter and the other asteroids with the in white.
The one with the 3 concentrations?
Yeah.
The one they video you showed.
Video.
Can you explain further exactly what's happening?
These are your asteroids in resonance. What's going on is anytime you have two bodies, and we're taking other planets out. You got the sun and you got Jupiter. There's going to be a gravitational neutral point 60 degrees in front of and 60 degrees behind. So these 2 points. There's also another one directly opposite. And this is the same for the Earth and the Moon system. Those are called Lagrangian points. And things collect there, or it's weird. There's a weird gravitational slope at those points. You can see these things. They orbit that point, but some of them, this guy here, is just going crazy. There's another one that just whips around and just going crazy. They can get kicked out sometimes, and they don't always have to stay in that orbit. But it's what I've heard of it referred to as is it's like something trying to do this and go over the top and not quite right. Like let's trying to do that. So that's what's happening at that point.
Basically the gravitational forces are such that it tends to force you back into the center of the area, whereas in other areas the gravity tends to pull you one way or the other, accelerating it. So it's what we call stable. And it's what we call the Trojan points, which really show up in the other version of this. But you talked about the Solar Dynamics Observatory.
Mm-hmm.
The Solar Dynamics Observatory is where we get all these beautiful pictures of the sun, and it's sitting out there about 1 light second in front of the planet. It's at L1. It's at the stable point directly between Earth and the sun. So it doesn't have to spin. It's doing this little kind of a halo orbit around that point.
It orbits the Lagrangian point.
But it's stable in that location, so it tracks between the Earth and the sun in a stable manner, so that it is able to. We don't have to spend propellant keeping it there.
James Webb is going at Earth, Sun, L2.
That's going out too. It's the one on the other.
Yeah.
It's
So the sun always blocks its view, or the Earth always blocks the view of the sun, so
Correct.
it doesn't get eaten.
Correct.
Okay, and a little follow-up on the previous video.
Mhm.
Why was there 3 and then 2
Right.
spots?
What you've got, you've got 2 different resonance points there.
I think they were selecting for the ones that were staying in the Trojans.
Right.
So
Okay, right.
in the second one, these are the ones that are in resident orbit. So they're actually traveling from each of those 3 stable points. Then when it flips, they'll show you the Trojans, and the Trojans are actually staying in those points.
Interesting to note that the orbits of these takes them right through the edge of the main asteroid belt on all 3 of the legs of that.
These are specifically the ones with relation to Jupiter.
These are the ones that are following this motion. Now these are you're selecting for the ones that are staying in the Trojans. So they're not traversing. So in a sense, it's a different orbit.
And you'll note these guys, they're staying a moderate distance away here from the edge of the main asteroid
Because the
belt.
thing to remember is that this is actually centered on Jupiter, so all of these are really in orbits of Jupiter, of the sun, that have the same, it has the same period as Jupiter itself. but in a sense, they're not really orbiting the sun, and that they're captured into the Trojan point of Jupiter.
Wish I had some good speakers on this thing. I got that shuttle launch with the, not with the, other questions?
Do you have anything on the Oort cloud?
No, I don't.
Okay.
I'm sorry, I can comment on it.
Yeah?
I heard some stuff just recently, I'm not sure whether I agree with it or not, but from the pictures I've seen of the Oort cloud, it's supposedly a sphere around the entire solar system. I've heard arguments that it's more like the asteroid belt. I've heard that there may not be nearly as many things out there as we suspect. Well, you know what? I'm going to wait till New Horizons gets out there and takes a look. Yeah, the New Horizons probe is a probe that's on its way to a flyby of Pluto in 2016, is it? 2015, I can't remember. It's 2015, 2016. It's going to be very exciting. I mean, Dawn is going to be at Ceres, Juno is going to be at Jupiter, and the New Horizons is going to be flying by Pluto. What's very interesting about that is it's going to fly by Pluto really, really fast. It's cruising right now. And it's going to be recording all this data, and it's going to be hitting all these different moons and stuff. They're actually they might have to alter its orbit because they discovered those 2 new moons of Pluto. But it's recording all that data, and then it's going to take 6 months for it to send all that data back to Earth at the incredibly low data rate they're having out there. From what I heard, it had a data rate of like 30K when it was doing a flyby of Jupiter. It's down to bits, like maybe 330 bits per second when it gets out there, and it keeps getting worse.
Could you comment on, wasn't there some story recently about NASA going to capture something and use it for training?
Yeah, there was some hubbub about one of the plans of having something go out and lasso an asteroid and bring it back. Nothing can go wrong with this plan.
Although a pretty small one, 25.
Yes, a small one. But yeah, when you start bringing those into orbit, you better make sure you
slow it down.
Trust the people that are working this.
And they were going to park it in a lunar orbit?
I think it was.
Pretty far out.
As far away as you can.
It's actually funny, because I'm taking an English class right now, and I brought that up to the teacher, because somebody posted an article, and I said, what could be the effects of doing that? Couldn't it throw something off? He's like, no, it'll be fine, things will be okay.
Something that small, I mean, those things pass by all the time. Now, putting one into orbit around the moon, that won't do anything. And if we could do it, I mean, the scientific benefits and the industrial commercial benefits would be a lot. I mean, when you talk about an asteroid, these guys from the asteroid mining thing yesterday, they were talking about a single medium-sized asteroid has more platinum metals in it than everything that was been mined at the Earth so far. It's got volatiles, water, and stuff like that. You can make the fuel, the rocket fuel that you need with that, and you can make the water that you need for that. So that's just amazing.
And the thing to keep in mind, though, like the one that the size they're looking at is small, and it's like the Russian asteroid-ish size or smaller. Like the real danger is extremely low, even if they really screw it up. Like,
Because here's some commuters in Moscow.
and it's good practice for the theories of can we take large natural objects and deploy technologies to move them, because that can be critical in long-range future. Might as well try it now.
You said that they would be coming to the open houses to check out telescopes. Do you have?
Yes, I have actually. I have a flyer here you can take. It's got a lot of information from here. I've got different links, web links for all the clubs and everything like that. So you can take one of these before you leave them.
And just a final comment, New Horizons, July of 2015.
I love the web. 2015 is going to be a busy year.
Yes, it is.
Yeah.
Two questions. What did you say was the smallest asteroid that was being measured and those ones are coming? What down to what size asteroid?
It's everything that they found, that information is
Down to
everything that they found.
everything.
Yeah,
They have them, the ones that get really, really close, they can see them smaller, so they got them down to meter size, I mean.
Oh, okay.
Yeah,
So there'd
yeah.
be even a lot more asteroids that are less than a meter that aren't even on there. Maybe
Oh, yeah, and I said, the discovery
Well,
rate.
it's in meter, it becomes from meteoroid to
The
asteroid.
the discovery, micro size up to 10 meters is a meteoroid. Anything above 10 meters is considered an asteroid.
Now, my other question, there's supposed to be a star in our neighborhood of stars that is in so many millions of years, it's actually, its course is that it's heading towards us. There's a-
Oh, you're talking about Genesis?
I don't know what it's called.
Are you talking about the dark twin that's supposed to be, our sun is supposed to be hit? I think
I remember that before. I mean, I actually asked about that. If there was something like a Jupiter or a brown dwarf halfway between here and Alpha Centauri, how could we tell? Well, we could, because if you looked at it in IR, you could see that in IR. So if there's anything, Jupiter is hot in IR. If Jupiter was halfway between here and Alpha Centauri, you could probably see it in IR. Not in visible light, but IR definitely.
There actually was a dwarf star of some variety, I forget, red or brown, that was found just a little bit closer.
Yes,
than
the Proxima Centauri, that was a very recent one. They found, I believe, it was a dual brown dwarf system. They found that, they found a dual brown dwarf star system closer than what had previously been considered the closest star system. How many other of those are out there?
Sort of going along with that, about, we didn't have giant Dennis Beetlejuice, once it goes supernovas, we're just gonna see it.
Oh, yeah.
And it's going to the nighttime, it's right there. It's
Daytime, you can see it. Daytime, yeah. I saw something on Facebook the other day. Does anybody ever look at Beetlejuice and say, will you just blow up already?
I'm just saying, what is it, like, it could be now and
Oh, it could be tomorrow, it could be hundreds of thousands of years. Plus is the life of stars.
right. But that would take hundreds of thousands of years to figure out how far away it is.
I think it's like 500 something. It's around 600 light years away. That's a comfortable distance. I think it's about 300. That's comfortable.
Yeah, if you want to see it, you better hope that it happened, 500 years ago.
Well, yeah.
Years ago, so you can, see it.
So, are we time?
You are over.
I am over, oh no.
You see, they're
Thank you
standing there
everyone for
going,
coming.
wrap it up.
Thank you.